Hey everyone, in this video lecture we will be solving your class 10 mathematics exercise 1.4. So starting with the first question, without actually performing the long division method means you don't have to perform the long division. State whether the following rational numbers will have terminating decimal expansion or non-terminating repeating decimal expansion. So the first question is 13 by 3125, and here you have been told that you don't have to perform long division method. Without performing long division method you have to do so. So what we have learned in the theorem? We have learned in the theorem that for terminating decimal expansion, the denominator of the denominator should be in the form of 2 to the power n, 5 to the power m. And for non-terminating decimal expansion, if we represent it in the form of fractions, it should not be of the form of 2 to the power n and 5 to the power m. So if the fraction is of the form p by q, these are the values of this conditions are for q. Okay, so we will check it out. So in this question we will solve this question first. So this is of the form, considering this is of the form p by q, so q is this one. So performing the prime factorization for this 3125, that is q, we will get 5 6 are 30, 5 2s are 10, and 5 5s are 25. Again 5 1s are 5, 5 2s are 10, and 5 5s are 25. Again performing the same for 5 2s are 10, 5 5s are 25. Again 5 5s are 25. So we got here 1 2 3 4 and 5 number of 5s we have got over here. So it can be easily written as 3125 is equals to 5 to the power 5. So this is of the form 2 to the power 0, 5 to the power 5. So it is of course of the form 2 to the power n, 5 to the power m. So this is a terminating decimal expansion. Okay, moving on to the next question. So our next question is 17 by 8. Here q is 8. So performing the prime factorization for 8, we will get 2 4s are 8, 2 2s are 4. That is 8 is equals to 2 cube, which is of course of the form 2 to the power 3, 5 to the power 0. So since it is of the form 2 to the power n, 5 to the power m, therefore this is also a terminating decimal expansion. Moving on to the next question. Performing the prime factorization for the denominator, that is 455, we will get, starting with 5 9s are 45, 5 1s are 5. Now again it won't be divisible by 2, 3 and 5, so the next prime factor, that is 7, we will divide it by 7 and we will get here 13. So here we can write 455 will be equals to 5 into 7 into 13, and it is not of the form 2 to the power n, 5 to the power m. Therefore this is non-terminating decimal expansion. This is non-terminating decimal expansion. Moving on to the next question. Question number 4, which is 15 by 1600. Again performing the prime factorization for the denominator, that is 1600, we will get 2 8 are 16 and 2 zeros, 2 4s are 8, Again 2 2s are 4. Again performing the prime factorization, 2 1s are 2 and 0 2 5s are 10 0. Again it will be divisible by 2 2 2s are 4 2 5s are 10 5 5s are 25. So here the number of 2 are 1 2 3 4 5 6. So it can be written as 1600 is equals to 2 to the power 6 into 5 to the power 1 and 2. So it is of course of the form 2 to the power n and 5 to the power n, and since it is of the form 2 to the power n 5 to the power m, it is a terminating decimal expansion. Moving on to the next question. So the next question is 29 by 343. Performing the prime factorization for the denominator, that is 343, the minimum number by which it would be divisible prime number is 7. 343 will be divisible by 7. So here we will get 49, and then again 7 7 ja 49 we will get. So here you can write it as 343 is equals to 7 cube. So this is again not of the form 2 to the power n 5 to the power m. So since it is not of the form 2 to the power n 5 to the power m, therefore this one is non-terminating or recurring decimal expansion. Now the next question is question number 6. You have been given as 23 by 2 cube into 5 square. So here, since this is the denominator and this denominator is of the form 2 to the power n 5 to the power m, here the denominator is of course of the form 3 is equals to 7 cube. So this is again not of the form 2 to the power n 5 to the power m. So since it is not of the form 2 to the power n 5 to the power m, therefore this one is non-terminating or recurring decimal expansion. Now the next question is question number 6. You have been given as 23 by 2 cube into 5 square. So here, since this is the denominator and this denominator is of the form 2 to the power n 5 to the power m, here the denominator is of course of the form 2 to the power n 5 to the power m, where the value of n is 3 and the value of m is 2. Therefore this is a terminating decimal expansion. Moving on to the next question, question number 7. You have been given 129 by 2 square into 5 to the power 7 into 7 to the power 5. So here the denominator is of the form 2 to the power n 5 to the power m. 2 and 5 is present, but along with them there is again something more, that is 7, and 7 to the power z I am assuming. So this is not the general form that we need. The general form should be 2 to the power n 5 to the power m. Therefore this is not equivalent to this, and therefore it is also non-terminating decimal expansion. Moving on to the next question. So our next question is 6 by 15. So before performing this prime factorization for the denominator in any of the question, you have to do one more step, that is you have to check whether this number is in its simplest form or not. This formula or this theorem is applicable only for them, those rational numbers which is in the simplest form. Okay, So this is not in the simplest form. It can be cancelled once again, because 6 can be represented as 2 into 3 and 15 can be represented as 3 into 5. So this 3 and 3 gets cancelled out and it is of the form 2 by 5, and now 2 and 5 are rational numbers. So here the denominator is 5. We will now check for 5, and the denominator is 5, so it is of the form 5 to the power 1 we have, and 2 to the power 0, since we don't have any factor for any power for 2. So it's of the form 2 to the power 0, 5 to the power 1, that is of course of the form 2 to the power n and 5 to the power m. So this is also a terminating decimal expansion. Now our next question is 35 by 50. As I told you in the previous question, you have to first check that whether the number is in its simplest form or not. So it's not in its simplest form, because 35 can be written as 7 into 5 and 50 can be written as 5 into 10. So this 5 and 5 again gets cancelled and it is of the form 7 by 10. Now this 7 by 10 is of the form simplest form. This cannot be factorized anymore. This cannot be cancelled anymore. So this 10 is the value of q, and now we will find the prime factors of 10. So the prime factors of 10 will be 2 5s are 10. So 10 can be easily written as 2 into 5, that is 2 to the power 1 into 5 to the power 1. So it is of course of the form 2 to the power n, 5 to the power m. So this is again a terminating decimal expansion. Okay, now the next question is, question number 10 is 77 by 210. So we will first check again whether this is of the form this is in the simplest form or not. So 77 can be written as 11 into 7, and 210 can be written as 7 into 30. Okay, so these two gets cancelled and this 11 by 30 is in the simplest form. So now we will find the prime factorization of 30. Performing the prime factorization of 30, we get 2 1s are 2, 2 5s are 10, and 3 5s are 15. So this is of the form 2 into 3 into 5 is equals to 30 we are getting. So this is not of the form 2 to the power n, 5 to the power m. Therefore this is again a non-terminating decimal expansion. So we concluded that whichever rational number which is of the form 2 to the power n, 5 to the power m, means the rational number whose denominator is of the form 2 to the power n, 5 to the power m, has a terminating decimal representation, and those rational numbers whose denominator is not of the form 2 to the power n, 5 to the power m, are non-terminating decimal expansion. Now the next question is, write down the decimal expansions. Now in this question you have been asked that the following real numbers have decimal expansions. You have been given some decimal expansions for some real numbers. In each case, decide whether they are rational or not. You have to find whether they are rational or not for every question. If they are rational, they will be of course of the form p by q. What can you say about the prime factors of q? Okay. So moving on to the first question. This question has a terminating decimal expansion, right? Means after 9 it just terminates, it does not keeps on continuing. So this is a terminating decimal expansion. And for every terminating decimal expansion, so since this is a terminating decimal expansion, this rational number is of the form, this is a rational number and this is of the form p by q, where q, we have to say something about what can you say about the prime factors of q. So we can say that this q is of the form 2 to the power n, 5 to the power m. Means This Q can either contain 2 as its factor or 5 as its factor or both 2 and 5 as its factors. Now, moving on to the next one. It's 0.120, 1200, 1200, 12 and 4 zeros, and the number of the digits keeps on continuing. So, since this is a non-terminating decimal expansion, this decimal expansion is non-terminating, and we don't know that what is the next digit that is going to come after this number of dots. So this is an irrational number. But the previous one was of the form p by q, and since it was a terminating decimal expansion, it was definitely a rational number. Okay. Now, coming to the third question, 43.123456789, and you also have a bar sign on top of it. Okay. So the next question is this. So, how will you do it? See, since this is a repeating decimal expansion, right? This is a recurring decimal expansion. So, in case of recurring decimal expansion, it can be represented in the form of p by q. Every recurring decimal expansion can be represented in the form of p by q. So, since it can be represented in the form of p by q, this is a rational number. But what can you say about the denominator of this rational number? What can you say about this q of this rational number? We can say that it is of course of the form 2 to the power n, 5 to the power m, but along with it, it contains some other rational numbers as well. Means along with 2 and 5, it contains some other number, or this is not only of the form 2 to the power n, 5 to the power m. Means whenever you get a bar over, you will tell that this is a rational number, but this is not of the form 2 to the power n, 5 to the power m. Thank you.